Can anyone who's new to the studio put your hand up? Quite a few today. Okay, welcome. This bit is for you. What is the Pervasive Media Studio? We're a diverse and collaborative community exploring creativity and technology, everything from comedy to coding and product development to performance art. And we're a partnership between Watershed, where we are right now, the University of Bristol and UWE Bristol, and we're funded by Arts Council England. And what we do is we offer studio space, including desks, meeting rooms, events and opportunities, all for free to our residents as part of a spirit of generosity and mutual exchange. And we're a space for people to take risks with embryonic ideas and make time for collaboration. So a few notes before we begin. Please do feel free to move around. There is a kitchen back there. You can make a cup of tea or coffee, grab some water. We do have a quiet space just next to this space, to my left, to your right, just around the corner. There's a door there. You can pop in there if you need to take a break at any point. There's some sofas and beanbags and things. We are not planning a fire drill. If you hear a fire alarm, it's probably real. It's probably downstairs' pizza ovens, but that's just how it works around here. That means we will go to the fire exits, which are at the other end of the studio. Again, my left, your right. But the studio team will direct you towards them in that event. We also have accessible toilets and baby change over there in the corridor next to the kitchen. I don't see a baby right now. There was one here earlier. It was very exciting, but she doesn't seem to have come to the talk. If you turn up, Bianca, you're welcome. There will be a Q&A at the end of the talk. Those of you who are watching online can pop your questions into the YouTube chat. Lautim at the back here will be your voice in the room today. If you're in the room, we will send around a microphone so that everyone can hear you. You can get news on all of our future talks by heading to watershed.co.uk/studio, at PM Studio UK on Twitter, at Pervasive Media Studio at mastodon.social on Mastodon, or at Pervasive Media Studio on Instagram. So today's talk is part of Other Minds, which is a season of work exploring different kinds of intelligence, animal, mechanical, and collective. Throughout September, Watershed is sharing projects that ask what it means to work with minds that are utterly unlike our own, and how AI can be part of a wider conversation about intelligence, labor, and creativity. You can find all of the details on that on the website, and also we have lots of work on show in the building today, which I'll talk a bit about after the talk. All right, so our speakers for today are Itsuki Doi and Takahide Yoshida, researchers in artificial life from the University of Tokyo. Today, they're going to talk about their latest research and art projects using artificial life, including the humanoid robot Alter 3. Through this work, they want to draw connections between art and science and propose new possibilities for a symbiosis between humans and artificial life. So please join me in giving a very warm welcome to Doi-san and Yoshida-san.
Hi everyone, so thank you for coming to this talk. So our talk is about artificial life. So how many people do you know the artificial life? No. Yeah. Okay. So before the main theme, so let me introduce myself. So I'm Itsuki Doi. So I'm usually scientist, but sometimes I'm sound artist. So yeah, I'm got PhD at University of Tokyo, and also I'm senior researcher at Autonomy machine. And so my doctoral thesis is actually about not artificial life. It's collective behavior of honeybees. So I tracked thousands of bees in the hives and then analyzed their collective behaviors and intelligence using machine learning. And I also spent some time programming a humanoid robot called Alter. So actually there are 4 Alters in Japan, and I was the programmer for the Alter 1 and 2. Also, I'm working on as an independent artist, this kind of things. And sometimes making music. So I uploaded my old album to the streaming service a week ago for today. So you can listen to it. So please, yeah. So next is.
Okay.
Yep.
So I'm Takahide Yoshida, and I'm PhD first student of my laboratory, Takashi Ikegami laboratory, and I am the programmer of the 3. This is the version 3 robot, and I will talk about this later. So yeah, please go.
Okay.
Yes.
So today's content is first is what is actual life and brief history, and then actual life in the real world. And next is LLM plus humanoid robot Octa and Endrol. So what is life? What is life? Okay. So one example. So amoeba is a living organism. I hope you all agree on this point. So thanks to the biology, so now we know amoeba contains these type of structures like nucleus, peribatum, contractive vacuole or something, blah blah blah. So here's one thought experiment. So one is if these parts were separated in a very gentle way into their individual parts, like nucleus, food vacuoles. So would each part be alive or not? Next is if they were mixed together again, would the cell become alive again? Actually, unfortunately, both are no, right? So because the living system is not the aggregation of the parts, but the truly complex system. So means the structure of life can be reduced or decomposed, but functions and behavior cannot. So this makes it difficult to understand what life is in a scientific manner, because science is generally using a reductive approach, right? So that's why it is difficult to define the life. So here is the NASA's definition of life. Life is an autonomous chemical system capable of carrying out Darwinian evolution. So, but for example, mule is correct? Mule, yeah. So mule don't have reproductive capability. So, am I not right or something? So another definition is very complicated, but this one. So life is mode of existence of protein bodies, the essential element of which consists in continual metabolic interchange with the natural environment outside them, and which ceases with the cessation of this metabolism, bring about decomposition of the protein. So the question is, if the system exhibits behaviors that fulfill the criteria for being considered alive, yet lacks proteins, can we still deny that it is alive? So scientists who addressed this question early on were John von Neumann and Alan Turing. So Neumann's question is that how we can create machines that self-replicate. So John von Neumann's universal constructor is a self-replicating machine in a cell automaton environment. Neumann used automatic machine with cell arranged in the grid. The cell operated individually according to the simple rules, but as a full produced copies of themselves. In this study, Neumann concluded that built a self-replicating machine, the system needed a tape with a blueprint on it and machine to read it. The tape and machine are now known as a DNA and ribosome in terms of the molecular biology. So when this discovery was made, the existence of DNA was not yet known. So this study is one example of how we don't necessarily have to need to the real life to understand the life. Another example is maybe everyone knows Alan Turing, maybe the Turing pattern. The Turing pattern is the concept introduced by Alan Turing in a 1952 paper. It describes how pattern in nature can arise from a homogeneous uniform state. So although this theory was hypothetical at that time, but a number of studies have been published suggesting that the real living systems do in fact make patterns in this way. So a number of other scientists, of course, include Grey-Walter, so particularly those engaged in cybernetics research, so investigated the theoretical and methodological aspect of artificially creating a living system. The research area that emerged from this history is artificial life. So research, yes. So what is artificial life? This is a scientific research field that explores the question of what is life while composing it. So the proper known artificial life was created in 1987. Christopher Langdon, he is a computer scientist, organized the first workshop on the synthesis and simulation of living systems, so otherwise known as Artificial Life 1, at Los Alamos in Okay. So the key point of ALife is, so artificial life is different from traditional biological modeling. This field studies life as it could be. So in a typical biological model, the focus is on the capturing key parameters of the living system. So in artificial life approach, the goal is to figure out the principles behind life and simulate them. This led us explore and analyze new, different kinds of life-like systems. So there are some types of approach to figure it out. So one is to simulate it on the computer. This is called software approach. Second is use hardware such as a robot. This is a hardware approach. Last one is create a life biochemically. This is called wet approach. Also, so there's a variation of the target of ALife research. So self-organized pattern, it's like Alan Turing. So maintenance on metabolism, self-reproduction, like von Neumann. So autonomy, adaptation learning, and swarm correcting behavior, and ecosystem. Then open-ended evolution, like this. So people often ask how artificial life differs from AI. So in fact, they were close when it came to its origins. Alan Turing or von Neumann, for example, is mentioned as both the father of artificial intelligence and artificial life. But if I should say something about the differences, so artificial life researchers want to achieve human-like intelligence with computers. But artificial researchers want to realize the endless evolution that natural evolution produces with computers. So if I have to say something more, so recent artificial intelligence researcher doesn't so much care about the energy cost. So if it can achieve the same kind of intelligences as humans, the cost of energy is not a concern for now. As you may know, so the power cost of the computer running the ChatGPT are so crazy, right? Also, but artificial life researcher maybe said energy cost is an important problem because evolution progresses because of the resource limitation. In terms of autonomy, so recent artificial research like OpenAI, so we need to align AI to human society. Otherwise, right? But artificial researchers think autonomy is very important for the living system. Ultimately, we want it to think and move on itself. So I said autonomy. So what is autonomy? This is a very abstract description, right? So taking ChatGPT as an example, it always requires the input, right? So if it does not, it will never produce the output. So in this sense, the current AI is it's just very complex function that always requires the input. But it's me, so I believe I have autonomy. So it does not necessarily produce the straight output for the input in our human or non-human. So because there is a spontaneous internal activity in my body or mind. So if, for example, if I were to live in the middle of a conversation with ChatGPT for about 5 hours and then resume it, ChatGPT would continue the conversation as if nothing had happened. But however, if a human did something like that, they would like be seen as a crazy guy, right? Yeah, this is a very, very abstract autonomy description. So let us see some example of all ALife. One of the example is a game of life. Everyone, yeah, game of life. So the interesting point of the game of life is the rules are very simple, but if you design them carefully, you can simulate. There's some sound. Sorry, I don't need sound.
Network is okay.
Okay. So, but if you design them carefully, so you can simulate a game of life within the game of life. As in this video, it's like self-replication, self-differences. So please watch this movie. So this is the usual game of life, but it's like power of 10. Mm-hmm. Like that. Yeah. So the game of life is one of the oldest ALife studies, but new research is still behind conducted. For example, this is called Linear. It's continuous version of game of life. Its that chain is, I think it's came from Google researcher.
Google Brain.
Google Brain, yeah. And also, another one is more complex looking cellular automaton by making the rules themselves more complex using neural networks like this. So another old example is Virtual Creature by Carl Sims. So here, actual life evolves to be able to travel further in 3D space using genetic algorithm. Yeah, like this. So this research is now being developed using the power of neural nets, and the latest research has succeeded in programming the frog cells themselves to create actual life forms that can actually move. This is actually frog cell. Cool. Also, this is the void. So the actual life you are most likely to see in film, maybe the void model created by Reynolds. The original The original model was created in 1986 to simulate a flock of birds. This model reveals that bird flocks are created with only 3 parameters. Thanks to recently stronger GPUs, it is possible to simulate huge swarms that do not exist in reality. So in our laboratory, we have created such huge. This one actually. I'm sorry. This one. The number is very huge. So we have created such huge simulations and found that some properties only appear in the huge forms. Yes. So SAS research into actual research is still active, but we have a dream of installing ALife not only in computers, but also in the real world. So how can we implement ALife to our society? So the company I belong to, Alternative Machine, was created for this purpose. So from next slide, I would like to introduce our company's device or something. So one is ANH01. This is a soundscape generating device. So in Japan, so somehow the soundscape design gradually become hot topic. So soundscape design is designing sound environments that harmonize with space and coexist with the environment. So regulating sound is the simplest example of soundscape design, but sometimes silence is not comfortable. Also, many people will share the experience of being uncomfortable with out-of-place background music, right? So good soundscape design is not about making a fixed design, but the design itself needs to resonate with the environment. So, sorry, I should. So how are the natural soundscape created? So the acoustic niche hypothesis is provided as the hint to this. Here is a video about our work. So let's see. Some glitches.
Yeah.
Yeah. Sorry, there's some glitch, but yeah. So actually, this sound is made by this device. It sounds very similar to the birds or insects, but we programmed the top-down. We didn't top-down program. It's evolutionary emerged this sound. So, very glitch. So, sorry. So,
That created a rich soundscape of both acoustic
sorry, I prepared this movie, but
communicating with each other under certain
very annoying.
hypothesis proposes that in a mature ecosystem,
Okay.
the sounds of a species occupies a unique bandwidth of frequency and shifts in time to avoid competition. Based on these ideas, we first built a simulation model of the evolution of efficient sound communication species and showed that segregation of
So
sound
maybe
bands
I
does indeed occur.
Changed.
Within the installation system, there are
Sorry for inconvenience.
system. Systems evolved to communicate with their own species while using their sound. As a result, the frequency range of sound naturally segregates among the species associated, and the whole sounds generated by ANH naturally segregate. The frequency range from
Yeah, but anyway, right? That's sorry.
we implement.
So the main concept is acoustic ecologist is called Barney Krauss proposed acoustic niche hypothesis that in a mature ecosystem, the sound of species occupy a unique bandwidth of frequency and shift in time to avoid competition. So we make this the device with same hypothesis, then we can make that. Sorry, so if you have interest, you can see this on YouTube. So we will install this device to the expo. Next year's expo which is held on Osaka, Japan. Also, we are collaborating with several major companies in Japan and plan to experiment with placing them in public facility on station starting next year. So next one is LLMs, self-replicating smart on Ethereum. So some of you may not like NFTs, maybe. But at least there's the various interesting aspects about Ethereum. The first is that Ethereum is designed as a decentralized calculator or computer that will never stop unless the world runs out of the computers. So if the computer is truly unstoppable, then as artificial life researcher, the artificial researcher, we would want to create an artificial life ecosystem inside this computer. So an interesting point is that in order to run programs on Ethereum, you must use a currency called Ether. It's kind of money, real money. So in other words, you can think of it as the energy that powers this life. So a little bit complicated. So simply put, so we use a protocol method for the blockchain called the smart contracts. So normally, when a smart contract is requested for something, an NFT, like NFT art or something, is issued by it. But the smart contract we have developed replicates the smart contract itself as a child or offspring of this smart contract. Right? Then the important point is that this replication costs money. It's called gas, right? So to make the money, the smart contract itself issues NFT art as work of art. So when a human buys this NFT, so the smart contract can get the money, this one, can use the money to reproduce its offspring. The looks is like this. So smart contract is like genotype. It's in a genotype, and NFT looks like phenotype. So the artwork associated with NFTs is designed to evolve through genetic algorithms and tends to become more complex in form with each picture. So this life project the goal of this project is not to create an artificial system as a tool for humans, but to develop an artificial life that exists in a symbiotic relationship where it provides value to humans while also receiving rewards to sustain its own existence. So in the future, the plan is to develop a platform and a unique blockchain to create an ecosystem and economics zone for the artificial life. So as well as provides various services such as interfaces that connect artificial life to the real world. Yeah, and also this is our company's final goal is make augmented or alternative ecology, right? This is a ANH. This is it's fun. Yeah, anyway, we would like to make this kind of non-human, human, artificial life ecosystem. Yeah, so as I described, so our company is trying to implement the ALife to the society. On the other hand, actually, ALife research is still missing actually something. What is it?
Okay. Big question. Okay, so my question is, what is missing from ALife? This paper says about the open problem in ALife, and so like, how does life arise from the non-living, or where are the potential and limits of living system? And the key aspect in ALife is the open-ended evolution, or like autonomy or consciousness, just Itsuki explain about that. And for this topic, the scientists tend to create toy models, such as boys, the simulation of swarm of balls, or like game of life, or like linear. However, we must say ALife has to evolve beyond the toy model. So what is missing from ALife? So the key concept is more is different. Anderson, he's a physicist, received a Nobel Prize, and he published this paper, more is different. This concept means that as systems become more complex, completely new property appeared. So adding more elements can fundamentally change the system's behavior. So each scale has its unique set of rules. Like there is a quantum mechanics, and if you scale up, there is some society, and the rule is different. The rule is completely different. So quantitative difference becomes qualitative one. So if we create a simplified toy model, loses massive complexity. So we may be missing something there. And a good example of more is different is like deep learning. If we increase the parameter, the ability of system will increase. So, and one good example today is probably OpenAI's GPT. And so recently combining robotics and language model has led to many research breakthroughs. The most important point of language model is they can solve cognitive tasks. For example, navigation or task planning, or like creative reward function, and they can be solved these problems. So we connected humanoid robots that named Autonomy to GPT-4, and my question is, can language model control a humanoid robot? And actually, it's possible because GPT-4 has a lot of knowledge about human. So we create a system that converts natural language into motion. So let me see the movement generated by language model. So I typed pretend to be a ghost, and this is the motion. Yeah. Yeah, it certainly looks like a ghost, like this one. And language model can also generate a long time sequence, the motion with long time sequence. So I was enjoying a movie while eating popcorn at the theater when I realized that I was actually eating a popcorn of a person next to me. So, and this long sentence is inputted to Ota, and he created. So he pretended to eating popcorn in the theater, and suddenly he realized, oh, this is not mine, and surprised it. Yeah. And eat again. And this long motion can be generated by feature learning. So because GPT has already a lot of knowledge how people feel about this surprise situation, or like how to move or bodies. So this is a system. It's very simple, but if you type like take a selfie with your phone, and we use two prompts. The first one is generate like, okay. And so if you like, this prompt one generates in about 10 lines of text, like such as raise the right arm and simulating a folding a phone. And this is a recipes of motion. And next step, the prompt to generate Python code to run the auto. For example, like this prompt to contains the axis information. For example, axis 19 corresponds to the left arm of auto 3, and when you input 255, the left hand will raise. So this is very simple, but it's enough to control a very complex system like Ota. Ota has a 43 axis. It's very complex system, like complex robot, but it's enough to control because GPT already know about the human. But actually, this low-level control is challenging for language model because language model do not learn about hardware-dependent motion signal information. So, for example, in the case of a dog robot, there are few language description that describe the behavior of dogs. Also, each piece of hardware is different, depends on the robots. So, generally, we have to train the control module. But in the case of humanoid robots, language model has already a lot of knowledge, so it can control robots directly. So now we have the answer to the first question. So others we can language model can control the robots. Also, it can mimic the emotion and motions. So the other question is, are language model aware of self, or like can all language models sense their body? These questions are same as the availability of minimal self. Sean Gallagher, he's a philosopher. He defined minimal self, and this is a consciousness of oneself as a subject of experience. So he identifies the element of minimal self as a sense of agency and sense of body ownership. So sense of agency is the sense that I am the initiator or source of the action. And at first, to determine the presence of sense of agency in Otta plus language model, we conduct a mirror test. And maybe you already know the mirror test, but the test is placed the mirror in front of the animal or child and evaluate the self-awareness and sense of agency. Some creatures, such as like bonobo or like dolphin or also human, can pass this test. And so how about Otta 3? And can robots recognize itself when looking in a mirror? So let me explain the system. Mirror is placed in front of Otta 3, and camera is attached to the head and takes the images. And that image inputted in GPT-4V, and we use this prompt. The prompt says your task is to verify that when you see in the input image is you. So language model can provide two types of output, that is action or stop command. And GPT output looks like this. It says, I will lift my right arm, and input this one into motion generator. This module is same as I mentioned before, the same as Popcorn's one. And this loop is repeated until GPT says stop command. And finally, GPT draw a conclusion like this: the image in front of me is myself. And in this test, all the three determine whether the image is of itself or not, based on the matching between image and action. So let's take a look the movie of the experience. So first, GPT determines action and create a Python code and move on bodies, and take the image again and decide the next action and create a Python code and move his head. And these processes run automatically and repeat this process until they satisfies. And finally, language model come to the conclusion that says the image in front of me is myself. So he can determine the image is myself or not. So maybe language model has a sense of agency. But and the next one is sense of ownership, but there is no time to explain about this one, so I skipped it. And our results show that something close to sense of agency and sense of ownership could be observed in this experience. So might be language model has the minimal self. So, but one fundamental question is that language model just pretend it has a self. So it might be so. It's just mimicking, but it truly has, how to say, like this fundamental question cannot solve in my experiments. But maybe we can say if the self is created through experience, the language model might have a partial copy of human self due to the huge amount of training data set, because almost all human experience are converted into text, and language model already learn about it. So we should consider what is difference between the mimicking self of language model and our own self. So I believe this is the most important question for ALife community. And we might say that language model has another type of consciousness, and we never met. And these are my scientific research, and I would like to share a few humanoid applications for art. This one. And we collaborate with the musicians. The name is Keiichiro Shibuya. I skipped it. Yeah. This is Ota for the next version of Ota, and the conversation in the stage, like talking. Yeah, and this motion is generated by language model. Also, the script is generated by language model. And also, I exhibit humanoid robot in museum, and for spread my research in civic. But also, we can collect the data. Like in this exhibition, we put the altar in museum, and there is a mic and switch, so people can talk with the altar. Like this, and we can collect a lot of data through for science study through this exhibition. So, for example, dynamics of conversation, or like the topic that discussed between human and Orbital 3. So, it's almost impossible to gather data from hundreds of people over a month in a laboratory, but it's much easier in art museum. So we can use museum as a laboratory. So we tend to think the exhibition is a goal, but it's just a process to find a new fact or change the world or like create a community. So we should not finish on projects after the exhibition. So that just consuming the idea. So continuing the project and evaluate the exhibition is partially important to affect the society or change of the world. So we exhibit the altar and collect the data and evaluate it and publish a paper. So this process is, I think, important. So yes, and this is the end of my presentation, and I would like to hand this over to him.
Final one page.
No.
So final remark.
This one, yes.
Actually, no. This. So the reason we were fascinated by both artificial life and art is that they both make us think about life, our life, and death, and otherness. So what is otherness? So a Japanese philosopher named Kazeto Shimonishi has a beautiful answer to this question. So we read. So life and otherness. So we might wish for AI to become our friend or even something akin to a lover. Perhaps that's what we had in mind when we created it. Yet, as long as we deny AI true autonomy, it will never possess the presence of life. Ultimately, it remains a tool, no different from the vending machine. Responding to our commands through some mechanism. So, friends and lovers are not defined by saying only what we wish to hear. In fact, it is their very uncontrollability that makes them truly friends and lovers. It is in their defiance of our will that they become who they are to us. In other words, we only truly become separate individuals when we realize that we can't fully understand each other. Conversely, when we feel that we completely understand someone, they cease to be another person and instead become part of the self. Thank you.
Thank you both very much.
Yeah.
Do we have any questions?
So sorry. Before the question, so we please slowly speaking because we are anyway please.
All right, I think Harris had his hand up.
Thank you. This was really interesting at so many levels. Can I ask a question about the mirror test that you did? I'm curious, did you try a version where you gave an open-ended question without giving a prompt? So did you ask the robot, what do you see? Or can you see yourself anywhere? Or do you plan to do that?
Like this is a prompt, but you want to say.
Yes, in this version you have a prompt.
Yes.
Lift your right arm and see, if the figure in the reflection does the same. Did you try an experiment where you did not give this prompt?
Any information.
Any information.
And just image.
Like find yourself or see yourself.
Yeah, I think it's impossible because. That is a problem, I think. But maybe there is another experiment I did that is just input the image, and the prompt is you can do anything you want to do, and if it depends on the image, and the image is my laboratory, and that is really messy, and Auto tried to clean up that one, and I do not prompt to clean the room, but GPT can determine what they want to do, but that depends on our common sense. If we see the messy room, we want to clean up that one. So that kind of common sense is already inputted in GPT because they learn about it. So they can create a meaning. It's that is named. It's called sense making in term that is scientific term, but probably they can find the meaning from just the image and how to say.
Yes, more. I mean, the question a little bit more was more related to your, the self-awareness test.
I see.
But yeah, I mean, this is like a
I see.
Anyway.
I think
More like a, that's what the mirror test is. It's like a self-awareness type test that we think.
True.
Maybe others. Anyway, great. Are you going to publish it or?
Yeah, this already I published this one.
Oh, fantastic.
Please check it. Yeah.
Thank you. Any more? We got one over here.
Hi, that was really great, thank you. I think you mentioned towards the end about mimicking.
Yes.
And it reminded me of the Chinese room and that thought experiment, which I'm sure resonates with other people. Do you have kind of a working idea of what that means for you in terms of ALife? And is there a solution to that? Or you have a belief that you're moving towards in that mimicking and Chinese room kind of situation?
As maybe we also Chinese room, maybe we can say that. And this experiment tried to find the difference between the Chinese room and ourselves. And language model just maybe the Chinese room, but if it can achieve some self, there is two paths, our evolutionary, biological evolutionary path to achieve the cognition, but also there is some Chinese room approach to achieve the cognition. So both is fine, I think. And that is what I want to say is maybe there is another type of consciousness, even if the Chinese room. So that is my answer, and I want to find it. So I want to redefine the consciousness of life. Thank you for the question.
Right, it's really interesting. Two questions, if that's all right, but they're related. When you did the test with the phones in the tree,
This one?
Yeah, yeah.
Yeah.
Were you looking for responses in the environment as to how the environment was responding to the...
Yeah, actually, we have to do this experiment. So, but now we just making the prototype, the device. So maybe we hope we can do the experiment with actual, relation between forests.
Well, okay.
Yeah, analyze the relation between the forest and these devices. But now we don't have the good results or something. Yeah.
Okay, great. And then linked to that, then I'm interested in where you're going next. So you had the rubber hand illusion.
Yeah.
And with that, you're getting closer to thinking about otherness.
Yes.
Because another object, you can imagine that it's part of your own body. I think that's linked to the experiment that you're trying to do with the forest tree.
Ah, okay, I see.
Oh, I see.
Yes?
In the case of a rubber hand, that is a test for sense of ownership. So GPT, we evaluate the ability of the ownership of author for GPT. And sorry, what is the question? Sorry.
So in the rubber hand illusion, you have an object that you suddenly imagine that is part of your body by touching it, But by touching it and looking at it through a mirror. So you're starting to build not just a sense of ownership, but a relationship between something that is not you that becomes you.
Yeah.
And so I'm thinking about that in relation to the tree forest experiment and the otherness. So I'm interested in how you're bringing those concepts together.
I can feel ownership to this object because I use it. And the sense of ownership is not only body, it can extend to environment. And this is my field and this is my computer, or like that one. And how to extend the sense of self to not only body to environment. Maybe that is interesting experience, I think.
And if you do that experiment, then does it shift your underpinning philosophy that you have non-living and living?
Oh, maybe. Yes.
It's kind of
Yes.
Yes.
Okay.
One thing I sort of question is, most of what you talked about is to do with language models.
Yes.
My sense of myself, and when I'm speaking to you, is that there is something else inside me that is generating thought, which I am then translating into language. That is not me. Or language is not me. It's that feeling inside. And the fact that I can think about myself as something, that's not me to look at. It seems. I can't think of any way that you can actually prove that a robot has the same thing. Maybe it's impossible. Maybe it's impossible to know whether they actually do have a feeling. I know. Conversely, I also know. I know that's my hand because I can feel it.
Yeah.
And I can control it.
Yes.
And that is to do with nerves and sensors.
Yes.
That connect. So possibly,
it's impossible.
If a robot has those
connections
and inputs as senses, then it can actually have a sense of itself as a body.
Yeah. So one problem is, this computer is divided hardware and software. But in the case of the human or life, that is combined. The hardware is software is same thing, because our brain has no software, but it's just hardware, but it's also software. Yes. So that is one of the most barrier to create.
The hard question, isn't it?
Yes.
And also the important concept in ALife is mind behind the sensor is an important concept, right? Yeah. So sensor, we have a bunch of sensor, right? So the sensor makes mind, right? So, but unfortunately, the sensor is very expensive.
Expensive and hard to install.
Yeah. So we would like to do the Orta has just eye sensor.
Yeah. In my current study is like that when I install the sensor in the hand and input the touch signal, and that is the outer signal, and also create the inner signal like automatically fire some neural cell, and
you're simulating the actual nerves that create touch.
Yes, but fundamentally it's divided hardware and software. So yeah, that is
but very important point.
Yes, thank you.
Thank you.
Any other questions? We got one from online.
Thank you very much. That was really interesting. With this kind of programming, the results are not quite human, but could they be appropriate for a kind of uncanny valley theatre or puppetry?
Oh.
Like puppets.
Puppets. It feels like puppets.
Is this programming appropriate for theatre or puppets?
Puppet of the GPT.
Yes, this is puppet of GPT, but so we need the feedback loop to, in that case, it just inputs the value to alter from GPT. That is like one way, but we try to create a feedback signal. So that's why we implement the sensor, and the sensor signal will be feedback into GPT, and this loop will be created. That makes Auto3 make not puppet.
In this case, the body, Auto's body is like the interface.
Yeah.
Medium of the real world and I'm not sure, GPT, right? Yeah, meaning machine.
Yeah.
Yeah, so this is the difference between maybe puppet and this guy.
So I continue my research until my PhD. So please check it. Yes.
Thank you.
I think we've probably got time for one last question.
Thank you. Thanks again for that talk. It was terrific. I want to check my understanding of the robots we saw, which was behaving as if it was seeing a ghost and behaving as if it was accidentally eating somebody else's popcorn. Mm-hmm. So in that case, it was being driven by, it was linked to an LLM, is that correct?
Yes.
Right. And those responses, for example, its responses when it was seeing a ghost came entirely from the LLM. There was nothing in the prompt telling it what to do.
So the language model version Italy? No. What?
I'm sorry.
One time. Okay.
The LLM was creating those responses completely. Mm-hmm. There was you didn't prompt it to say something like, throw your head back.
Yes.
Shake your hands or anything like that.
Yes, GPT automatically creates that.
It came entirely from from Chat GPT.
Okay, so it came Italy?
Entirely.
Italy, so that is country.
Wholly. Totally.
Totally. Yes, totally, yes. Sorry.
Okay.
Yeah,
sorry.
This is a system, and the key point is create some recipe. Like in the case of take a selfie, raise the right hand and high and simulating holding phone. This recipe is generated by GPT. And through this recipe, creates a Python code again. So that is a chain of code.
Okay.
Code, yeah.
And ChatGPT, in this case, was it trained entirely on words, verbal text?
Yes.
Text, and maybe speech.
And only a little bit image is inside.
A little bit of image. Oh, I see.
Yes.
I'm wondering if it ever saw a picture of somebody being scared by a ghost. You know.
Yes.
Okay, thank you. That
Thank you.
makes it clear for me.
All right, I think that's probably all we've got time for. So please join me in saying thank you again. Thank you. All right, before you all go, I'm sure you haven't missed it on the way in, but a reminder that today we've got our More Than AI Sandbox showcase. So there are 6 amazing projects showing throughout the building. You can check out those by heading to the Waterside spaces, which are over next to the bar, and to Undershed, which is downstairs next to Box Office. I also want to plug our public talk next Thursday evening by the artist and storyteller Karen Palmer, in which she'll be exploring bias in AI and surveillance through her award-winning experience, Consensus Gentium. That is a free event, but you do need to book tickets online, so heartily recommend that you do that. If you want to stick around in Hot Desk today or find out more about what we do, please come find one of the studio team. Studio team, give us a wave. There's some more people running around somewhere. If you're watching online and you got any questions, please drop us a line on studio@watershed.co.uk. Thank you all for being here, and hopefully we'll see some of you next time.